day, grade 9 learners. Welcome to today's mathematics lesson. My name is Rose Mtimunye, and this lesson is proudly brought to you by the Gauteng Department of Education. So, today we are still continuing with exponents, and we are going to focus on integer exponents. So, these are your negative exponents, alright? So, make sure you have a calculator next to you and you have your workbooks ready for today's lesson. And also do save our WhatsApp line 064-748-8913. This is where you send us your questions, you send us the work you've done, and also any other comments that you might have regarding today's lesson. You send them to 064-748-8913. Right, now let's look at the lesson objectives for today. By the end of this lesson, you should be able to extend the general laws of exponents to include integer exponents. And we are focusing on the law that says when you have a raised to the exponent negative m, it's the same as writing a fraction, 1 over a to the power of m. So basically you invert the base, okay? And you change the sign of the exponent. So your pre-knowledge from grade 7 and grade 8, your laws of exponents. You remember we've learned all our laws, so you need to remember those. We will be applying some of them today. Your multiplicative inverses, your integers, and as well as your order of operations, right? This is, like I said before, order of operations. You need to keep it in mind every time you do your calculations. All right, so we have a baseline assessment. With this baseline assessment, I'm going to give you time to copy the full baseline assessment and start with the first 4 questions, right? Then we'll answer those questions before we move on to number 5, 6, and 7. All right, so I'm going to give you 4 minutes to answer number 1, 2, 3, and 4. Okay, you have 4 minutes for the first 4 questions. Welcome back, grade 9 class. So I had asked you to do number 1, number 2, and number 3 and 4, right? So we are going to start off by doing those solutions for those ones before we move on to number 5, 6, and 7, all right? Okay, now let's look at the first one. It says simplify the following and leave your answer in exponential form. I'll just go back quickly. All right. Now you are given a fraction here. It's 1 over 3. This required for you to remember some of your exponential laws and the definitions we have learned before. I hope you still remember some of them, okay? Which one of our exponential laws can we use that gives us 1? Do you still remember that any number raised to the power of 0 is equal to 1? So that means here we could have written 1 as 3 to the power of 0 over 3 to the power of 1. You know that if you have not written an exponent, the base is actually being raised to 1, right? So 3 to the power of 0 is the same as 1. Okay. The reason we're doing this is so that you can see where we are getting the answer we are now going to get. We apply now our law for when we are dividing powers with the same base. What do? We subtract the exponent. So we're going to say 0 minus 1. And this will give us 3 to the power of what? Of negative 1. Right. So if you got 3 to the power of negative 1, then you are correct. Well done. That was the first one, right? Then the second one says, write 1 over a to the m without a fraction. So you had to do the same thing like you would have done in number 1. Okay, I'll write it underneath. So 1 over a to the m will be equal to 1. We can write it as a to 0. So a raised to the power of 0 over a raised to the power of m. And then from there we say, okay, we are dividing powers at the same base. So we are going to subtract the exponents, which means you're going to say 0 minus m. Okay? And from here, we must have a to the negative m. So did you get a to the negative m? Do you send me your pictures of all your solutions on 064 748 8913? I'd like to see how you are doing. And also if you have questions or you don't understand where we are getting all these, just remind me, let me know so I can remind you of the laws we are applying, okay? All right, now let's look at number 3. Number 3 is 2 over 4, right? And you also have to write that in exponential form. So here, what we are going to do, we can leave 2 as 2 to the power of 1. 4, how can we write that as an exponent? As 2 squared. You still remember 2 times 2 is equal to 4, right? Okay. Then now we can just apply the law we have been applying. We are dividing powers with the same base. Therefore, we are going to subtract the exponents. And 1 minus 2 will give you a negative answer, which is negative 1. So finally, when you write 2 over 4 in exponential form, it becomes 2 to the negative 1. Okay, then you get another mark. So far, I hope you all have gotten the correct answers. You may not have necessarily used the same steps, but I'm trusting that you have the answers. Okay, we're now going to look at number 4. So for number 4, it's 9 over 81. So here we need to write 9 in exponential form and 81 in exponential form. Every time you're not sure what to use to write your numbers in exponential form, just go back to using your prime factors, right? If you go back to using your prime factors, it will make your work so much easier. So you write 9 as a product of its prime factors and 81 as a product of its prime factors. Okay, so 9 is the same as 3 squared. Okay, I hope you can see that. All right, so I'll say everything I write. And then 81, how do we get 81? You will say 3 to the power 4, because it's 3 times 3 times 3 times 3. Okay, you can check that on your calculator. All right, once you have that, you can now apply your law. Powers of the same base are being divided, therefore we have to subtract the exponent, and 2 minus 4 will give you how much? It will give you a negative 2. So here you have 3 to the negative 2 is your final answer. All right, those were neat questions, weren't they? Like, they're the best. Okay, now for number 5, I'm going to ask you to please take 3 minutes to answer number 5. And then if you finish in time, do send me your solution, and you can also continue with number 6 as well, right? So you're going to have 3 minutes for number 5. Welcome back, class. So let's look at number 5. Okay, number 5 says 2n times 2 to the negative 2n divided by 2 to the negative 2 raised to the power n plus 3. So this is the fraction we are working with. It looks a little bit complicated, but if you apply the simple laws that we've learned for exponents, it'll be very easy for us to work through the topic. Okay, thank you very much to Unity Secondary School. So far you have sent in beautiful work. Thank you so much. I appreciate the fact that you're showing all your steps and your work is neat. All right, and then now Kenneth Masekela Secondary School has asked for assistance with number 5. Okay, so I'm going to keep giving you ideas, and then I'm going to ask you to work a little bit ahead of me to correct your work. All right, this is for Kenneth Masekela Secondary School because you have asked for assistance with number 5. Okay, Now, the first thing we have to do here is to look at our numerator, okay? Our numerator has two bases, all right, two powers that are being multiplied. Do you notice that? And then these powers both have the same base. What law can we apply for when we are multiplying two powers with the same base? Do you remember your law? Okay, so the law says that you must, when you are multiplying powers of the same base, what do you do with the exponents? You add the exponents. So that's where we must begin, okay? We don't focus on the whole fraction. We look at part of the fraction, which is the numerator first, okay? Because our ultimate perfect fraction will have one term at the top and one term at the bottom. Okay, so let's do the first step to this question. Let me draw my line. Right, so I have 2 to the power of n, and now I'm supposed to add all the exponents because the bases are the same, they're both 2's, right? So we have n plus, be careful here, use brackets, okay, 2n, okay? And you leave your denominator as it is for now, do not disturb it. All right, I know some of you can immediately apply all the laws in one step. If you did that, that's also okay, okay? But this is to help those people who need to be reminded of what laws to apply. Right, so we've applied the first law, so we just have to simplify here. So we'll have 2, what's n minus 2n? That's the same as having a 1 minus 2, which gives you a negative 1. So we'll have a negative n in our exponent there. And then at the bottom, we still have 2 to the n plus 3. Okay, now I'm going to continue below my fraction. So from here, I'll just say equal to here. What law can we apply now? Do you notice that we still have our bases as 2, but this time we are dividing the numerator and the denominator. So you can actually apply the law that says when you're dividing powers with the same base, you must subtract the exponents, right? So that means from here we can say 2 to the negative n minus, right? This is where some of you may have made an error. You use your bracket and say n plus 3. Why do you do that? You do that because I'm writing equal to the n, the negative here has to be multiplied inside the bracket, okay? So that means you're going to have 2 to the negative n minus 3. Do you see that? Okay. Now you have two like terms from here. We are going to continue at the bottom. You have 2 to the negative 2n and minus 3. This is your final answer for this question. All right, I'm just going to give you some time to copy it. So what did we do first? The first thing we did was to work with our numerator because our numerator had two vectors that were being multiplied, right? And then those were powers of the same base, right? So we applied our law and said, okay, we are multiplying powers with the same base, and we added the exponents, right? Once we had added the exponents, we now had one term over one term. All right, great. Then next, we are now dividing powers with the same base. So we subtracted the exponents. That's when we said negative n minus our bracket n plus 3. Then we multiplied the minus sign into the bracket. So we said negative times the n and also the minus times the plus 3. And we got minus n, negative n minus 3, right? And now you see you have your two like terms here. So we collected these two like terms, and those gave us negative 2n, and we're left with minus 3. So this is what we have, 2 to the negative 2n minus 3 is our final answer. Okay, I hope the learner from Kenneth Masigela now has an idea of how to do this question. All right, we're now going to move on to the next question. Okay, the next question, I'm just going to give you 2 minutes simply because now you have an idea of how to answer this question. So you have 2 minutes to answer this one. Welcome back, class. I realize some of you might still be continuing with the solution. That's okay, you can continue, and hopefully when we start and do the solution, you'll be able to correct your work as you keep going with the solution. Okay, all right. So here we are multiplying powers of the same base in the numerator, and then when we look at the whole fraction, we are just dividing powers with the same base. Do you see that? Okay, so we'll start off by working with our numerator. Okay, right, now let's look at our numerator. Here we have 5 to the 2n minus 3 times 5 to the 6 minus n, right? So this means that because we are multiplying powers with the same base, we have to add the exponents. So we say 5 to the 2n minus 3 plus 6 minus n, right? You can use a bracket here. Multiplying the positive and the negative will still give you a negative. Okay, we haven't touched the denominator yet, so we just write 5 to the n plus 3. Okay, what do you do from here? Now we have to collect like terms because the exponent now looks a bit complicated, doesn't it? Okay, let's identify our like terms. We have 2n there and negative n there. What do they give us? We get an n, right? And then this one, negative 3 plus 6, what do they give us? They give us a positive 3. Remember, we have integers with two different signs here, so we just subtract and keep the sign of the bigger one. So we said 6 minus 3, and we got 3, and 6 was positive, so that's where we get our positive sign. Or you could have used your calculator, right? Now things are starting to look a little common, don't they? Now we have the same thing at the top and the bottom. I know some of you immediately realize the answer is equal to 1, but you need to be very careful here. Always let the mark allocation also guide you. This type of question could end up being out of 5 or out of 6, which means you need to extend that to get all the marks that you need. All right, so from here we are now dividing powers with the same base, so we have to apply the law that says that we must subtract the exponents. Okay, note now, because I have a minus sign, I am using my bracket, and showing it. Okay, so from here you still have that minus n minus 3. Then you collect your like terms one more time. So you have an n there and a minus n there. That will give you a 0. Okay, and then we have a plus 3 and a minus 3. That will also give you a 0. So we actually just have 5 to the power of 0. And 5 to the power of the 0 is the same as 1. This is our final answer. Okay. All right. Now for this question, it says simplify and write 10 to the negative 2n divided by 10 to the n with positive exponents. For this question, I am just going to give you 2 minutes and then we'll do the solution. Okay, class. So for this question, what you had to realize was that you are working with powers with the same base. So you immediately could have subtracted the exponents. I think that would be the one way that most of you would have chosen. So let's just use that and say 10 to the power negative 2n minus n. Okay. And then this will give us 10. So you have negative 2n minus n. So these are like terms, and we end up with negative 3n, right? Now, do you remember back from number 1, number 2, number 3, all these questions? How did we end up with a negative fraction? We just had to invert the base, right? And change the sign of the exponent, and that would be a 1. Do you remember that? Because at the top here, your 1 is actually 10 to the power of 0. Do you see that? Okay. So what I'm looking for here is for you to have this as your final answer. Okay. All right. So now we are going to get straight into our lesson. We've taken a bit of our time on this assessment. Okay. But I'm very proud of the fact that the learners that are sending us their work, they are actually showing good remembrance of all the exponential laws, and you're actually writing the laws on the side, and I appreciate that very much. Okay, now let's go back and remind ourselves of some of the notation that is associated with exponents, okay, and especially the expressions, okay. So here, the 4 represents a coefficient, okay. Now, a coefficient is the factor that is joined to the variable. The word factor tells you that this number is being multiplied with the variable, okay. And then you still remember that your a here will be the base because it's the one that is being raised to the exponent, right? So This is the number that is being multiplied by itself a certain number of times, right? And then the exponent, which is the x here, you also know it as an index, right? This is the number that tells you how many times you must multiply the base by itself. And don't forget that a to the x is actually your power, okay? And that is an expression to show that a number is multiplied by itself a certain number of times. I know you still remember some of this. The most important thing here is just for you to add a 4 in front or a 2 or 3, and note that this is a coefficient because it's not being raised to an exponent. Your power is just the base and the exponent. Okay. Now let's have a quick refresher on negative bases. Right. If you have -1 raised to an even number, you need to remember you will get a +1. Because when you multiply -1, let's say we have an even number such as 2 in the exponent, we would say -1 times -1, right? So that means we are multiplying a negative by a negative, and that will give us a positive. This is where we get +1. You can repeat that process as many times, okay? As long as you have an even exponent, you get a +1. So in general, for any integer that is a non-zero integer a, you'd have -a raised to an even number, right? And if you have -a raised to an even number, your solution will be a positive integer, okay? Also, -1 raised to an odd number will still give you -1. Think about it. -1 to the power of 3 will be -1 times -1 times -1. Okay? Let's write it so you can visualize it. -1 to the power of 3. 3 is our odd number. It's this number. What do we get? We get -1 times -1 times -1. So here we are multiplying a negative and a negative. This gives us a positive. And then this positive and that one will give us a negative. So here we have a -1. And that's where we get the -1. Okay. So now, if it was any other integer that is a and not 0, what would you have here? You'd have a -a raised to an odd number, and your answer will also be negative, okay? Right, so let's look at these two examples. So now we are just going to apply that law we've just learned and work with our integer exponents, okay? So number 1 would be out of 6 marks in a typical test, okay? We'll see where we get some of those marks when we do the steps. All right, so we have a fraction, -8x cubed over x to the power of 8 times 2x squared over x, right? So what we want to do here is to first convert the 8 to its prime basis. So we used 2 cubed, okay? Simply because I can see that on the right hand side, the other fraction is also to the power of 2. So I want my bases to be the same when I apply this law, okay? So from here, if you notice, you still remember your rules. You must multiply your tops by your tops and your bottoms by your bottoms, right? So numerators by numerators and denominators by denominators. So that means you can just simply extend the line of division all through across the sign. And then what do you have now? You now have -2 cubed times x cubed times to the power of 1 times x squared in your numerator. At the bottom, you have x to the power of 8 times x to the power of 1. Now, this is your new fraction, right? Now, because you have that, you can then apply your law, the first law of exponents. When you're multiplying bases, powers with the same base, you add the exponents, okay? So, from there, that means we can say 2 to the power of 3 plus 1, okay? And then the x's at the top, we have x cubed here and x squared there. So we say 3 plus 2. We add those two exponents, okay? Here we have x to the power of 8 and x to the power of 1. So we add 8 plus 1. Right. Just be careful. Do not get rid of your negative. Remember, your fraction started off as a negative fraction. So do make sure you keep that negative sign all throughout your calculations, okay? So here, 3 plus 1 will give you 4, and 3 plus 2 will give you 5, and 8 plus 1 will give you 9. You can still do more. Do you notice that you have a base that is the same in both the numerator and the denominator? So that means we can actually rewrite this and subtract the exponents for the x base and say 5 minus 9, right? So now we have negative 2 to the power of 4 times x to the power of 5 minus 9. And what's 5 minus 9? It's negative 4, right? And from there, we just apply our law. What do? We invert the base. So that means if it was in the numerator, we write it in the denominator, okay? And we change the sign of the exponent, right? So this is for x to the negative 4, right? So it becomes x to the power of 4. And because here it was being multiplied, we then divide. That's where it goes to the denominator. All right. Therefore, that's your final answer, negative 2 to the power of negative 2 to the 4 divided by x to the 4. Okay, now let's look at number 2. Here we have powers of the same base, but they also have coefficients in front of them. So first we must make sure we multiply the coefficients, all right? So we're going to say 3 times a negative 6, okay? And 3 times negative 6 will give you negative 18. Then from there, you can now apply your law. You are multiplying bases, powers of the same base. Therefore, you're going to add the exponents. So you're going to say negative 2 plus 3 for your x. And then for y, you're going to say, okay, this y is raised to the power of 1 there. So you have 1 plus negative 5, which is the same as 1 minus 5. Okay, and then from there, you now have, you keep your negative 18, and you, negative 2 plus 3 is 1, and here 1 minus 5 gives you negative 4. Right, now with the negative 4, we want our exponent to be positive. Therefore, we move y to the denominator and we change the sign of the exponent. Okay, so your final answer is negative 18x divided by y to the 4. Okay, so I hope you understand. We are still applying that very same law. Let me remind you, that says that if you have a raised to the negative m, this is the same as having 1 over a to the m. Okay, that's basically the law we are applying all throughout here. Okay, now sometimes this law is more useful if you are going to be working with values. So at times you'll be required to use the law, but you'll also be given values for the unknown variables, so for your x's and your y's, right? So this means that you can actually be able to determine the value of the exponential expression. Okay, now if you still remember from your algebra, this is when you'd apply your substitution. You take the value that's given for x and you substitute it into the expression. Value given for y, you substitute it into the expression, right? Then you do your calculations, right? Now, depending on the type of expression and how complicated it is, sometimes you can choose to simplify first and then substitute before you get your answer. At times that might be too risky and you just end up just substituting. All right, so here we have an example. It says determine the value of 3x squared minus 5x to the negative 1 if x is equal to negative 2. Okay, so here every time we see x, what do we have to substitute? Negative 2. All right, so we write down our expression, right? 3x squared minus 5 to the 5 times x to the negative 1, right? Okay, don't complicate it by going on to fractions first. Immediately substitute your value for x. So we substitute negative 2 whenever we see x, right? So we have 3 times negative 2 all squared minus 5 times negative 2 to the power of negative 1. And then from there, you now can start applying your law. Remember, this law still works with numbers, right? So we know negative 2 squared is 4. And here, this can be written as 1 over 2. What did we do there? We inverted, right? We took the 2 from the numerator and we put it onto the denominator. Remember, negative 2 here is the same as negative 2 over 1. All right, so we just had to invert that. Take the numerator, make it a denominator. And then the sign of our exponent has changed. It's now a positive 1. Okay, and then 3 times 4 gives you 12, right? With this one, you just multiply your tops by your tops, so your numerator by the numerator. 5 times 1 gives you 5. And then the negative times the negative is where we got this positive sign, okay? And your denominator will still be 1 times 2, and that gives you 2, right? So you just write this as a mixed number, the improper fraction. So you say how many times can I take out 2 from 5? I can do it twice, and I'll have a remainder of 1. So you write the 1 as 1 over 2. Okay, now what do you do from here? From here, you just add the whole numbers. 12 plus 2 gives you 14. So your final answer for this expression is 14 and a half. Okay. All right. I think you have copied this. Don't forget to ask us your questions. 064 748 8913. All right. Okay. Now we have an activity. All right. I am going to give you 5 minutes to answer these questions. All right, apply the skills we've just learned using our baseline and also our examples. When you're done, we will discuss them. So you have 5 minutes. Welcome back, class. So, number 1 already has 7 marks. I hope you've accumulated as many of those marks as possible, okay? Now, you know the first thing when we work with substitution, we write down our expression. So, it's a half multiplied by a to the negative 2 times b to the power of 3, all of that squared, okay? Now, this is what we are working with, right? So, we are told that a is equal to negative 2 and b is equal to 2. So this means that where we see a, we must substitute negative 2, and where we see b, we must substitute positive 2, all right? Be sure to use your brackets. That way when you raise the numbers to the exponents, you're actually raising the whole value to the exponent. If you have negative 2 and you don't put it in a bracket, the negative 2 that is in the exponent will just be for the base 2, which means your base is actually a positive base being raised to a negative exponent, right? And that would be incorrect, okay? So make sure you use your substitution, okay? Your substitution bracket. Right, so far all we've done was to substitute negative 2 and positive 2, where we see a and b. What do we do next? The next thing for us is to now write or simplify our exponents. So negative 2 raised to the power of negative 2 becomes 1 over negative 2 squared, right? So all we did here was to invert our base, which means we moved it from the numerator to the denominator. And then what did we do as well? We changed the sign, right? It was a negative 2, now it's a positive 2. We changed the sign of the exponent. Okay, so we still have the same fraction. Then what's 2 cubed? 2 cubed is the same as 2 times 2, which gives you 4, and 4 times 2 gives you 8. So our answer there is 8. Okay, now let's see. So far, just for substituting, you get a mark. For writing this as a positive exponent, you get a mark. Knowing that 8, 2 cubed is 8, is also giving you a mark. So far, you had 3 marks. All right. Right, then from there, all you have to do now is to remember, it's easier to work with fractions by fractions. When you're multiplying, you multiply your fraction with a fraction. So what did we do? We converted negative 2 squared to 4, because it's from negative 2 times negative 2. This gives us a negative times a negative will be a positive, and 2 times 2 is 4. Right, so we've done that part. So we have 1 over 4 times 8 over 1. Remember, all whole numbers can be written as fractions, right? Okay, so we are still dealing with what is inside the bracket. Don't worry about the exponent outside the bracket. So from here, we say 1 times 8, and that will give us 8. And 4 times 1 will give us 4. And then here, that's where we get 4. We divide both sides by 4. Yeah. Right, so you can say 4 into 8. Okay. And you get 2 either way, right? So now we still have that exponent that was outside, so it's 2 squared. And 2 squared is the same as 4, but because I'm still working with a fraction, I just rewrote 4 as 4 over 1. And from there, you just have 1 half times 4 over 1. So you have 1 times 4 and 2 times 1. Numerators by numerators and denominators by denominators, right? So what's 4 divided by 2? That should give you 2. So your final answer will be 2. I hope you have your answer as 2 and you actually did this showing all your steps. Okay. All right. So let's see. We were 3 marks, right? So the simplified bracket will get us a mark. This step and that, or also this one, by the way. Okay. So this is where we get our 7 marks. All right. Let's look at the next one. The next one is very direct. It says you must first simplify and then you calculate the value, okay? So for this question, we had to first simplify the expression. So we write down our expression. We notice that our expression is actually a product raised to a power, right? Do you see that? So That's for the numerator. So we have to distribute the exponent inside the bracket. So that means we have to raise 4 to the power of 3 and x squared to the power of 3. That's 2 times 3, and that gives you 6, right? Because you have to multiply the exponents. And then y to the power of 3 raised to 3 will be 3 times 3, which gives you 9. Okay, that's where we're getting those. And then we still leave our denominator as x to the power of 4 times y. From there, we now say 4 cubed is the same as 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 gives you 64. And with the x's and the y's, we are dividing powers with the same base. So we have to subtract the exponents. I hope you notice that. So here we say x to the power of 6 minus the 4, okay, from the denominator. And in our numerator, we have y to the power of 9. So you have to subtract 1. Remember, this y is raised to the power of 1. Right. And then from there, you just simplify. So say 6 minus 4 gives you 2, and 9 minus 1 will give you 8. Okay. So just for getting here, this question is out of 8 marks, right? So for having 64, there, get you a mark. And for this correct step will also get you a mark. Distributing the exponent correctly also gets you a mark. Okay. And then from there, so you've done the simplifying part. Now you have to substitute, because they said, and then calculate if x is equal to -2 and if y is equal to -1. You have to calculate the value of the expression. So you can just substitute in the simpler expression. Do you see that? So we say 64 times -2. We still raise it to the exponent of x, so -2 squared times -1 to the power of 8. Okay, right, just substituting correctly, another mark. Okay, this is the importance of showing your steps. This is how you get your marks. Okay, then once you've done that, you can now apply the exponents. So -2 squared gives you 4, and remember, -1 raised to an even number will be equal to 1. So it doesn't matter how many times you multiply it, as long as it's an even exponent, it will be equal to +1. Right, so now we have 64 times 4 times 1. So we're multiplying 64 and we get 256. So this is your final answer. Okay, so you get a mark there. Alright, now for finding the correct exponents, -2 squared and -1 squared will also get you a mark. Alright, your answer is usually out of 2, and then you'll also get a mark there, also 2 marks. Alright, I hope some of you at least were able to simplify the expression, and I trust those of you who actually did the substitution, you started it after simplifying, because here your marks come from simplifying and then substituting. If you substituted immediately, you'd find that you get 3 out of 8 or 4 out of 8, right? It also depends on how lenient your marker would be. Okay, the next question says simplify, all right? And then you have 2 fractions. One fraction is 3/4, and this one is raised to the power of 5, right? And then the other one is 4/3, and it's raised to the exponent -3. Right. Now we know that we have to write the 4/3 raised to the -3 as a positive exponent when we work with it, right? Now let's see how we do that. Think about it as 4/3 to the -3. I'm writing it. What would I do? I would have to distribute the exponent inside. So I'd have 4 to the -3 there, and 3 to the -3 there, right? Now both of them have negative exponents. How do I write them with positive exponent? I would have to say 3 cubed there and 4 cubed, right? That looks like 43. Anyway, right. And then from here, what do? We then have to apply the rule here for multiplication. Okay, so we are starting off here. We are dividing. So when we multiply, this is where we get back to that fraction. All right, because now we had to invert this and bring the 3 cubed to the denominator and the 4 cubed back to the numerator. That's how you end up with 4 to the power of 3 in the numerator and 3 to the power of 3 in the denominator. Okay. All right. Once you are able to apply this, remember just changing your division sign to a multiplication sign and having the correct fraction there will get you a free mark. So never skip the step, always show that step, okay? And then from here, remember you are multiplying your numerators by numerators and your denominators by denominators. I'm just showing you that step, okay? So this is not with marks. Right. Now you need to notice here, what are you doing here? Actually, dividing powers with the same base. So you can say 3 to the power of 5 minus 3. And 4 cubed, there you can write 4 to the 3 minus 5, right? And then what do you do from there? You just simplify your exponents. So 5 minus 3 will give you 2 for 3. And then 4 will be raised to the power of negative 2. Okay. Can we leave it like this? We could, but we actually do know what to do with the 4 to the negative 2, don't we? And we also know what 3 squared is, right? So we know we can write 4 to the negative 2 as 1 over 4 squared. And what is 1 over 4 squared? 4 squared is 16, right? And 3 squared was our numerator. So we can multiply those two, and 3 times 3 gives us 9. So we'll have 9 over 16 as our final answer. Okay, so well done if you got this solution correct. Remember, you can keep sending us your questions and your pictures of your solutions on 064-748-8913. All right, this is your homework. Could you please take a quick picture of the 2 questions that we have here? So while I'm on screen, just snap a quick pic so that you are able to practice this homework at home. All right. Okay. So I've answered most of the questions that you have sent through. Thank you very much to Unity Secondary School and Kenneth Masikele for your questions. And we have answered those questions. So we are going to move on to our summary because those questions have been answered. All right. Okay. So with your summary, just remember that when you are working with your negative exponents, if you have your base being raised to a negative exponent, you can write it as 1 over the base raised to a positive exponent, okay? And also, if your base was actually positive and you need to learn the laws basically in reverse, right? So you can say 1 over the base raised to a negative exponent if your base is positive. This will be helpful if you're asked to solve some questions, especially in algebra, okay? All right, and don't forget with substitution, what you need to do, you need to make sure you substitute using your brackets, okay? And this will help you to be able to calculate the correct values. Don't forget that the reason you also need those brackets is so that when you're raising the value to the exponent, you're raising the whole value, including the negative sign if it has a sign. Okay. So the steps to follow, you first substitute the given value in for the variable and then you calculate. Right. So in the next lesson, we are going to be looking at performing calculations that involve all 4 operations using numbers in exponential form. So now we are just going to be problem solving exponential laws, okay? Thank you so much for joining us today. This lesson is proudly brought to you by the Gauteng Department of Education. Please remember to sanitize, wear your mask, and keep social distancing. My name is Rose Mtimunye, and I will see you in the next lesson.